let's solve ARML individual problem 6 from 2024. In the left figure below, the cell in the fourth row and third column of a 9x9 grid is deleted to obtain a set S of 80 cells. For each n from 1 to 8, an L-shaped tile Ln consisting of 2n plus 1 cells is given, as shown in the figure at right. Compute the number of ways to tile S using these 8 L-shaped tiles, each exactly once with rotations of tiles allowed. So let's just ignore the restriction that, and let's just add in another 1 by 1 square, that's L0. And we don't have this missing black square thing. Okay, so now let's place L8. So L8 can either go like here, it can go here, it can go here. Wait, actually this is extended. Or it can go here, or it could go here. So there's 4 possibilities for where L8 goes. And wherever L8 goes, there's 4 more possibilities for L7 because after we place L8, we'll be left with the 7x7 grid. And so there's going to be 4 ways to place L7. And so there's 4 ways to place L8, 4 ways to place L7, and so on. And then down to L1, where we need to place L1 inside this. And there's 4 ways to do that. And after we place L1, let's just say it's right here, then L0 is determined right here. So then, without this restriction, there's 4 to the power of 8 ways. But now we have to deal with the restriction. So our answer is going to be obviously less than 4 to the power of 8. Okay, so let's just call something like this. Let's just say we have a tile that's like this somehow. It doesn't matter if it's L1 or L8 or anything. Let's just call these types of tiles NE. North and east. Okay, and now let's call like these types of tiles where it's like a 7x7 or 6x6 or whatever, SE for south and east. And let's call these types of tiles, let's call these SW for south and west. It doesn't matter, again, it doesn't matter. And so then we have one more, which would be, which would be north and west. And that would be something like this. Okay, so now we've labeled all of these things. Okay, so now that we have this, now that we've defined all the terminology, let's get to solving the problem. Okay, so basically the key, so let's find like how many NW pieces there are, how many N's appear. So let's just say we list out all the pieces that we use. So for example, there's going to be one L8 and it's either NW, SW, NE, or SE. And let's just write all of them out from L8 to L1. So obviously we're going to have 16 of these letters, 2 for each piece. Okay. And so it turns out that there's going to be 3 N's, 5 S's, and 2 W's, and 6 E's. Why is this? Well, it's based on the positioning of the black piece. Because, okay, so if we have an N, this is because, like let's just say we have an N, okay? So then it's either this one or this one. So it's going to be, we have these if and only if we have these only if it's above the if it's above the black square. So there's 3 things above the black square. So we're gonna have 3 N's. And similarly, there's 5 rows below the black square, and so we're gonna have 5 S's, and so on for west and east because there's 2 of them to the 2 things to the 2 columns to the west and 6 columns to the east. So then it's 3 norths, 5 souths, 2 W's, 6 east. And so now basically we want to find So now that we have these, the question is simple because it's 8 choose 3 because we want to choose the because we want to choose the north and the south, and then it's times 8 choose 2. And so this is 1568, which is the final answer. If you like this video, please like and subscribe. Thank you.